Hello, everyone. Thanks for having me one more time this year. I'm super glad to be here, so thank you. Today's presentation will be all about OMR 11, our newest OMR release. As usual, just before we dive into the big topic, a brief introduction of myself. My name is Rita. I am Portuguese, currently living in Portugal, Lisbon. I have a master's degree in electronical and computer engineering with a specialization in telecom. I work at QXIP, or QuickSIP, your preference, and I am an engineering lead and director of Cloud Ops, and I've been working here for 2 years now. Today, I want to introduce you to OMR 11, but to do it properly, I believe you deserve to know a bit more of what happened behind the scenes. So today's agenda will start with a brief overview of what is so challenging about telecom observability that makes us need a specific tool for it. Exactly the reason why we developed OMR in the first place. Then we will take a look at the OMR history to see how we developed OMR in each release to answer the telecom demands as those evolved, leading us to today, OMR 11. Then, of course, I will show you everything about OMR 11, the functionalities, the features, everything that's inside the new backend that's completely made from scratch, the decisions that we took, and the reasons for those. But before we end, because I know you guys want to really see something, so I will have a preview of some specific use cases on the new OMR UI. So, what's hard about telecom observability, really? It doesn't look that complicated until you actually need to do it yourself. What you thought would be done with just some logs and alerts turns out to be a lot harder and complex than that. Modern systems already stretch the limits of observability. With distributed architectures and microservices, you have fragmented data silos. All the logs, metrics, traces, and profiling from a single application are unified in theory, but in practice they are scattered and uncorrelated. And as our systems and services scale, so does our troubleshooting data. And it scales exponentially. This causes high cardinality, which is a problem for both cost and performance. It gets to a point where you have too much data. It's hard to handle and even harder to correlate and make sense out of it. Now, on top of all of this complexity, you add telecom. Because unlike general systems, VoIP, mobile, or any other real-time communication product and service has a specific layer of telecom complexity, dedicated complexity, starting with the protocol hell. Protocols like SIP, RTP, RTCP are not your everyday logs. So this means that these protocols by nature are stateful, multi-step, and bidirectional, which basically means that for each transaction you have a lot of events. Well, why is it a problem? Because when you use standard tools like, for example, Prometheus and Grafana, yeah, you can see the events produced, but not what they mean in the telecom logic. So you have them available, but you cannot easily correlate, for example, a SIP invite to a one-way audio bug. Yeah, good luck with that with just logs alone. Also, the majority of you, as I understand, have a combination of open source and closed vendors. When you use proprietary tools like SBC, soft switches, and stuff like that, this means that when you are troubleshooting these tools, proprietary tools, you have proprietary schemas, logs, and APIs, which by itself wouldn't be a problem until you actually need to troubleshoot it. Because when you try to gather everything together to correlate and make a sense out of it, basically it's really hard and basically means that you don't have a single source of truth unless you build it yourself. So all of this combined causes that you have limited visibility. And with limited visibility, you have limited control. You don't know what you can see. So problems like mid-path failures, signaling timeouts, and net issues often go undetected or even uncorrelated. So most often, you know there's something going on with the calls, but you cannot tell the root cause for it. You don't see it. So all of this combined is exactly the reason why made us develop OMR in the first place. OMR was built for one purpose, to make telecom observability practical. OMR was born in the field, built by and for engineers dealing with any type of real-time communication challenges. It is built around HEP, our native protocol, that is used for encapsulating both signaling and media metadata. OMR offers correlation-first observability, giving you context, not just logs. This adventure started many years ago, and I think you guys know it because some of you even used Omer 3. And with Omer, you can expect that odd releases are LTS releases, and even releases are dev releases are experimental. So, after Omer 3, the first LTS release, came Omer 7, which for years has been the community's favorite and the one that simply works. And after 7, we developed and delivered Omer 10. A dev release, yes, but with a killer vision and way more powerful than anything that we did before. And right now we are entering the Omer 11 era, the next LTS release. But the point here, guys, is that using Omer is just not about capturing packets. It's about being able to understand what's going on with the calls and the real-time services. So, doing a deep dive starting on 7 until today, 7, as I said, has been the holy grail solution for years now. It stood the test of time and it's still being used by many companies today. Omer 7 is fairly easy to deploy and maintain. However, when we built it and delivered, the telecom world was different, and so were its challenges. Nowadays, with microservices everywhere, with cloud-native workloads and distributed schemas and applications, Omer 7 powers feel a little bit limited. For classic SIP troubleshooting, Omer 7 remains unmatched, but for the modern world, the battlefield has changed. Nowadays, we need more than just the HAP packets. We need to correlate those with logs, metrics, traces, and sometimes even profiling data to be able to answer and clearly tell the health of our systems. So if you are still using Omer 7, you're not wrong, you are just due for a power up. And on the road for that power up, we developed and delivered Omer 10. Omer 10 is a visionary tool compared with 7 and compared with any of the previous Omer versions, really, because Omer 10 is the first one that is a full stack observability solution. This means that starting on Omer 10, you have it all in one place. The HAP packets, the logs, the metrics, the traces, and the profiling ready to troubleshoot and correlate together. However, Omer 10 the level of power it holds is almost the same as its complexity, because it unites protocols and data types, but overlooked that not all users want to build their dashboards from scratch. On 10, the fact that we don't have the dedicated UI and API led a lot of you to skip it entirely. Also, on 10, we are still using ClickHouse. This means a server DB. We all know that handling a server DB is hard, costs a lot of money. If you need distributed systems to scale, everything gets harder. However, the 10 was a huge learning experience and served as our lab for the future. From it, we forged Omer 11. Omer 11 is about to be released, and to start, I want to assure you, like it happened in previous versions, we are compatible with all the HAP agents that you are using out there in the market. And, of course, as it is to be expected, Omer 11 is fully open source, meaning 100% free. Secondly, yes, we are bringing the Omer dedicated UI and API back. You will no longer need to rely only on the Grafana integration to see the call flow. If you missed the UI, you will have it back, an improved version of it. However, if you are one of the few that actually enjoyed having the call flow inside Grafana, you don't need to change the way you troubleshoot today. You will have it too. On 11, we are supporting both options. In terms of management, Omer 11 will be the simplest one yet, because managing it will be just like managing folders and files. The data that Omer 11 produces will be all stored in Parquet files. So everything that you need to worry about are files alone. Besides being super lightweight and simple, we offer other benefits, starting with the formats. You don't have any type of format constraint. You can insert any time series, HAP packets, telemetry, doesn't matter, because like it happened on 10, Omer 11 is also a full stack observability solution tailored for telecom. In terms of DBs, Parquet files are compatible with almost any tool out there in the market right now, so you are able to read these files according to your wishes, you store them where you please, it's your data, so it's your choice. In terms of architectures, it will match any requirement that you have. If you have the requirement for a specific cloud provider, bare metal servers, distributed architectures, microservices, doesn't matter, Omer is fully compatible. In terms of licenses, I mean, there are none, as it is to be expected, because everything inside Omer is open source, so you don't need to worry about that. In terms of clients, you can use basic SQL queries to see your data. You can take advantage of Grafana, the Omer UI, or your beloved tools. You just integrate with Omer 11 APIs, and that's it. So basically, you can expect no pain. It is easy to deploy, configure, and maintain, and it is built to last, like a proper LTS release. But there is one more thing worth mentioning. Omer 11 is AI ready. So we have 3 default providers that you can integrate natively, which are OpenAI, DeepSeek, and Ollama. You can select one of them to use for your AI prompts. However, if you have other open source LLMs that you prefer, or even if you have your own LLM, doesn't matter. You can integrate natively with Omer 11. The only requirement is that the model must be compatible with the OpenAI or Ollama API formats. But this is the only requirement. Then you can integrate whatever you please. So, using this feature, the Omer AI Assistant basically means that you can make any type of question correlate different files, different schemas, whatever it may be. You make the question and you get the answer. Also, if you are not a fan of building dashboards, it's no longer a problem. You go to the Omer AI Assistant and you ask for the dashboard that you need, and it creates it for you. So basically, you get insights to improve your network, you get root cause analysis, and even dashboards made for you. So imagine a world where your observability tool could explain itself. Omer 11 is that tool. As I mentioned before, the backend is completely new. Why? Because when we decided to remove the server database requirement, everything kind of became a possibility again. We went to the market, investigated the latest and greatest features, and this is what we came up. So, Omer 11 uses Arrow to structure all the data that is ingested, both telemetry and the app packets. Arrow does it blazing fast and in memory. Once the data is ingested and compacted inside Omer 11, it is stored in Parquet files. These files can be read using any compatible tool, and they are really good because they are great for long-term storage, compression, and selective queries because they are columnar and they are optimized for large data sets, exactly what we have in Telecom Observability. To query and access the data, aka reading, we are using Flight SQL. As I said, for the Parquet files, they can be read using almost any tool nowadays. But in our deployment, we chose to go with DuckDB. The reason being, DuckDB is fast, efficient, and requires no servers. So it's not a server DB. Omer 11 doesn't require DuckDB to be running to be able to create the files. It just uses DuckDB alongside Flight SQL to be able to read. That's it. Also, we already developed and released some native integrations for DuckDB, so it just made sense to use it. In terms of data lakes, we created our own as well, App Lake. Why? Because we wanted something tailored for telecom observability, which means writing once, reading many times, either locally or in the cloud. Also, the fact that we produced our own data lake means that basically, we can develop specific features that we believe will benefit you on the troubleshooting. For example, the storage cascading layers, which basically means that when you do an SQL query, you have the hot, warm, and cold layer. Hot meaning in memory, warm meaning locally on your disk, and then you have the cold, which is object storage. So basically, Omer 11 is a proper DIY of ours. Reason being, this is the truly way we can ensure no usage fees and no vendor traps. But maybe now you're thinking, sure, you did everything yourselves. It means that you can control it. But there are a lot of tools out there in the market, and it seems like you are reinventing the wheel. Well, this is not entirely true, and the reason being that nowadays most of the really good tools out there in the market are first and foremost paid, meaning commercial, or they are open core instead of being fully open source. And this is something that we are strong believers of the open source community. So we prefer to take no risks and develop something that we know and can assure will always be free, instead of choosing something that starts as free and then in the future having them pulling a ready streak on us. We decided to slowly remove ClickHouse from our stack because it no longer suits the community's requirements. Managing a server DB is hard, costs a lot of money, and slows everything down. When distributed architectures are a requirement, maintaining consistency is a nightmare. All of a sudden, you require double or triple the nodes just for data consistency alone. We know this very well because in our commercial products, some customers need data replication. So we are familiar with both the operational costs and infrastructure costs of these setups. Also, ClickHouse is no longer fully open source. It is open core. So using it in our commercial products, completely fine. Using it in Omer is out of the question. In terms of data lakes, indeed, there are a lot of good ones out there, like, for example, Antalya, Duck Lake, Iceberg, just to name a few, but they are not tailored for real-time observability. They are tailored for general analytics. And in Omer, we need telecom observability, meaning real-time, we need low latency, everything to be ingested immediately. So they are not really suitable for our use case. Doing our data lake means that we can, sure, control it, but create features and tailor them for you guys. And as it happened for ClickHouse, the same kind of applies to other open source DBs in the market. Either they are too complex and server DBs, which are absolutely a no-go due to their associated costs and a heavy maintenance, or they are not tailored for real-time observability. Finding an open source DB that is suitable for our use case is not something that comes around very often. So we decided to just use Parquet files and DuckDB. Okay, now that you know the decisions for the new backend, it's time to see the architecture and how it really works. Starting with the ingestion part. Here you can ingest HAP packets, and to do so, you need HAP agents. So, as I said, any HAP agent out there in the market using HAP version 3 is fully compatible. For example, FreeSwitch, Kamaili, OpenShips, Asterisk, just to name a few. HAP is an open source protocol, so anyone can develop an HAP agent and use it to ingest HAP packets, even commercial vendors. Besides HAP, you can also ingest telemetry data, meaning any logs, metrics, traces, or profiling from your applications and network can be ingested towards Omer 11 and correlated back to the HAP packets. Any agents that are OTel compatible or line protocol compatible are supported. To name a few, Promptel, FluentD, OpenTelemetry, and Grafana agents are a few examples. After ingesting the data, there's the routing phase and data processing phase. The true magic of Omer 11 happens here. So, as we reviewed, you can ingest two different types of data, send them towards a single endpoint Omer 11. It will read the data and create the Parquet files on the fly and store them. But how does it really work? When you ingest any of the possible data types, Omer 11 normalizes this data in memory on fly using Arrow. This ensures compatibility with the different telemetry formats and the HAP packets. Omer has a schema on write serverless query engine, which means that you can ingest traffic, add or remove columns on the fly, leaving reconciliation to the reader. So basically, when you have a specific data type and you need to add a column, for example, to correlate, you don't need to do anything besides ingesting. You ingest the data, Omer 11 takes it, writes it, and when you go and read the data, the entries that have it show the value on that column. The entries that don't show the value as null. That's it. For the reading part, we are using FlightSQL, which provides minimal latency and a super fast query engine. While you are ingesting, reading, writing, troubleshooting, Omer is also compressing these files on the background. Reason being, this enables you to, with the same amount of storage, have much more data on this version. So, you ingested everything, you know how it works, it's time to troubleshoot. You have many options, starting with Grafana. If you are familiar with it, you can create dashboards, make the SQL queries, do almost anything, including our integration, which enables you to see the call flow. Then you have our new UI, everything made from scratch also. The code base is in React and it's still under development. And the part that we are still working on is the call flow because we know it's the most important. What we have already working is the Omar AI Assistant, SQL queries, and the dashboards. But what happens if you don't want to use our tools, neither Grafana or the Omar UI, to troubleshoot? Because you have your setup, you have your use case, and you have your beloved tools already. It's not a problem. Omar 11 produces data that is yours to store, to query, and to use, so you can keep using whatever you like. You just need to integrate it with Omar 11. And to integrate, you have 3 options. Option number 1, going with the HTTP API. This one is for simple clients. It's ideal for UIs, scripts, and glue code. It's a human-friendly interface for day-to-day ops. Then you have the Flight SQL API, which uses Arrow. This one is for real-time, high-performance access, built for native clients, BI tools, and analytics engines. It leverages the speed and structure of Arrow and SQL. And then you have the most powerful one, which is go with the files directly. So, direct file-based access to the Parquet files, and this one is ideal when you actually know the data schema. And with this one, you have 0 lock-ins because you can move the files, share them, or analyze them as you please. This is a strong point of Omar 11 because on previous versions, whenever we found something cooler, better, that would suit you guys better, we needed to do a new release, a new version, change everything. And you would need to take care for migrations. It's really hard for you to keep up with all of these versions, and we know it. So with Omar 11, we broke the cycle. We rebuilt the architecture from the ground up with 3 guided principles: being telco specific, being 100% open source, and being modular by nature. This modularity means that whenever a better tool emerges in the future, and it will, we can just replace it, that part that needs it, and you don't need to care for a full migration. It's just that module that changes. This makes Omar 11 future-proof because we can upgrade and innovate without a new backend again, basically. But one thing is for me to say all of this, another thing is for you to see it, so let's see what we have in the UI. So this is the new UI, and the first thing that you will see when you go there, when you do the deployment, is a presetted dashboards that are used for you to be able to answer one question. Am I having an outage, yes or no? Basically, we are seeing here that 3 dashboards relating with SIP metrics, the count per SIP method, the completed call ratio, and the session establishment ratio. We are taking a look for the last 5 minutes, but you can click here. It's a drop-down menu, and you change the timestamp. Also, you can create as many dashboards as you please, and you can customize them all, including the ones that we set it as a preload dashboard. You just click on these 3 dots, you go to the query, change it, save it, that's it. Then you have the query interface. So here is where you do the SQL queries to see your data. First cool feature that we added were the tabs. Segregated context, you just click on this plus sign and you can create a tab. This means that if you are working on multiple support tickets, you have segregated context, you can have, or you can be working on multiple and different SQL queries, and you have the results, the DBs, the timestamps, all in separate tabs. The names are also customizable. Then you see here the DB name and the from, which is the table. These are drop-down menus that you can click and they are preloaded. This means that you don't need to know the data schema by memory, nothing like that. These are preloaded. All the files that Omar 11 can see, the data structure, it will tell you what's inside. What's the DB? You select the DB that you want, and then when you click on the from to see the tables, it only shows tables that are matching inside that DB. In my case, I'm making a query to see the count of SIP messages grouped by buckets of 5 minutes for the last 6 hours. Again, drop-down menu, you can click and change. Then you have the results on the down part, right? But you also can see directly from here a dashboard. You just click on this panel and you have a dashboard matching your SQL query. You can change the type of dashboard that you want right here. It's a drop-down menu. You can give it a title. I don't know what's going on. Okay. Okay, I don't know who this is, but I will just... Is it a call? I'm an iPhone user. I don't know how to manage this. Where should I click?
This is real life telephony in action.
Sorry. No problem. What was I saying? Yeah, you can give a title to the dashboard, and it's not visible here, but you can scroll down on the actual UI, and you can save this dashboard directly to the Dashboards tab. Finally, the Omar AI Assistant, the place where you can just make any type of query. But querying what? So you have dimensions, and here you will say, or you will see all the DBs and tables available for Omar UI, so you give it context. So the model knows what you are talking about. Then here is where you select the model. On my case, I have a llama, but any connection that you made prior to this will show up here. It's a drop-down, you select what you wish. So, on my case, I made a query to see a dashboard showing calls with jitter bigger than 200 milliseconds and grouping them by destination IP to see if I have a pattern. I'm looking for the last 6 hours. Again, drop-down menu, click and change according to your wishes. And if you are pleased with this dashboard, you can just click on Save It, and you will have it there forever to take a look later. This was really speedy, I know, but we are about to have the Lunch and Learn, where we are going to take a look into more use cases, more complexity with the action, so make sure to don't miss it. Just to reinforce again, this is an LTS release. Omar 11 will be here to stay for a while, and it is already available for you to test it. We have a demo on GitHub, so just go, clone it, start testing. You can already open bugs and ask us questions. But before you do, please remember, support open source before asking open source to support you.
Love it, Rita.
One more closing note.
Go on then.
With Omar 11, we are not just watching the network anymore. We are understanding it, commanding it, and evolving with it. The fellowship has forged the tool. Now it's time to wield it. Thank you.
Thank you, Rita.